This video is going to be about wormholes. Now, we'll get to the point why there's a black hole here later. So, let me just tell you what a wormhole is. Right, so, a wormhole, or what's called an Einstein-Rossen bridge, is this hypothetical tunnel structure that connects two points in space-time. Now, what I want you to imagine is that space-time, this 4D fabric of the universe, is a sheet of paper. Now, normally, to get from A to B, you just travel along the surface. Now, a wormhole is basically folding the paper in half, poking a hole through it, which creates a shortcut between A and B. Now, the origin of this idea came from Einstein and Rossen, hence calling wormholes Einstein-Rossen bridges. Now, in 1935, they discovered that the mathematics of general relativity allows solutions where two black holes, hence black holes, are connected, what we now call an Einstein-Rossen bridge. Now, originally, this wasn't thought of a traversable passage, but more or less a mathematical curiosity. Now, later developments, physicists like Kip Thorne in the 1980s explored these, or whether wormholes could be stable and traversable. Now, these studies linked wormholes to science fiction ideas, like faster than light travel and time travel. Now, there's a couple of different types of wormholes. I've gone over them, let's just go over them again. Now, they're all hypothetical, mind. So the Einstein-Rossen bridge is a black hole paired with a white hole from a one-way connection, and it's unstable. The traversable wormhole is a tunnel that you could theoretically travel through without being destroyed. It requires exotic matter to keep it open. Now, a time machine wormhole is a wormhole with ends moving relative to each other that could allow backward time travel, and this is just highly speculative. Now, the problems with wormholes are that they're very unstable. Wormholes could collapse pretty much instantly after forming. In order to keep them open, you need negative energy or exotic matter, which is stuff with less than zero energy density, which doesn't exist in usable amounts yet. Second point is radiation. Any radiation falling into the wormhole could build up and completely destroy it. And the third one is that traversable wormholes might allow time travel, which could lead to paradoxes. Now, the strange thing is why they even matter. Why do wormholes matter? That's a really good question. Well, that's why I'm going to answer it. They show the flexibility of Einstein's equations in describing the extreme space-time geometries. They inspire ideas for quantum gravity, which I'll cover in one of my other videos. This is the bridge between relativity and quantum mechanics. And they appear in speculative physics, string theory, and the ER equals EPR conjecture, which suggests wormholes and quantum entanglement may be connected. Look at my last video, quantum entanglement, to find more about that. And now, wormholes in pop culture. Interstellar, the 2014, was a scientifically inspired depiction. Star Trek, Stargate, and Marvel, they often use wormholes as portals for faster than light travel. Now, these depictions usually simplify or exaggerate, but they keep the very core ideas of wormholes, that they're shortcuts in space-time. Now, here's the different interpretations and theories about them. So, general relativity, wormholes are allowed by equations, but they're unstable without exotic matter. The quantum field theory suggests exotic energy exists in small amounts, but not enough for macroscopic wormholes. String theory suggests that sometimes worm-like objects, it predicts these wormhole objects. Now the ER equals ERP suggests that wormholes, ER bridges, and quantum entanglement, EPR, might actually be the same thing at a deeper level. Now, here's a little bit of a summary. Wormholes are theoretical tunnels in time-space that connect distant regions. They're mathematically possible in Einstein's relativity, but physically unstable. Now, to make them traversable, we need exotic matter or new physics. They also link the ideas of black holes, time travel, and quantum entanglement. Again, go view that in one of my other videos, which makes them one of the most exciting frontiers for theoretical physics. Now, I did mention radiation back in the problems with them. Now, my next video will be on certain wave types and radiation, so stay tuned for that. Thanks for listening. Stay smart.